Well, hi, good morning, and thank you so much for joining me here on November 14th. Another gray, a little bit rainy day here. Oh my gosh, where has the blue sky gone? I don't know. It's not here. So, okay, so I finished doing the capacitors down in this area, the old paper capacitors, and there's a few more left in here that I can see. It's one here, big one. This is a big one here. These ones are going to be, my guess, based on their location, part of the IF, involved with the IF, or certainly the front end of the radio. Oh, there's one tucked right in here. Looks different. It's a very different type from these. Occasionally, there's a special capacitor put in these radios, which is designed to counteract drift due to warm-up. So as the radio warms up for 20-30 minutes altogether to bring it up to its final temperature, during that time some component changes can take place and the radio can drift. So occasionally there's a capacitor designed to counter that drift, and you got to be careful. If you go to change that one, maybe you shouldn't. Or, in today's world, you don't really care even if the radio drifts a bit. It's not a big deal. So, but that's something to think about. There's also quite a number of these black molded capacitors in here. My experience with those has been good, in the idea that they don't leak and they seem to maintain their capacitance. So I'm going to leave all those alone, certainly at the start, unless there's a real reason for me to consider changing one of those. I wouldn't bother with it. Even these old ones I'm changing out aren't affecting the operation of the radio that much, at least not so far. So, having said all that, I think the first one to go after is going to be this big guy here. So we want to find out what this is. What's it doing in here? Now, I could take a guess. My guess is it's on the screen circuit of the two front tubes. But let's take a look at the schematic, see if we can find this. Maybe we'll start with a layout and see if by some chance it shows us that capacitor there. Here we go. Okay. Okay, we're looking at the layout diagram, and this capacitor is at the back of the radio, not far from the antenna terminals. Back of the radio, not far from the antenna terminals. So right in this area, it's located right here. Who's here? Would this be? This isn't working. Is it C9? Maybe it's C9. They show C9 screen grid. Okay. And grounded to this. This is a ground point. So it's going from the screen grid to ground. It's pretty sure it's just what I said it was. C9. Okay, let's see C9. So it's going to be one. There it is, C9. And it's a 0.1, and physically that's kind of what it looks like size-wise. And it's located on the screen grid, so it's going to be sustaining some high voltage. The screen grid circuits carry a fair bit of current, so a little leak through here wouldn't have much effect. But if the effective capacitance of this begins to fall, then it's not going to be doing its job, and there's going to be consequences. So let's go get this guy and replace him. And how well is this radio working? It seemed to work kind of okay. I don't know if we would really notice any difference. There could be a difference, but not enough for us to notice. Unless I put a lot of instruments on the radio, and I'm not going to do that. So let's just change this guy out, and we'll chest him. What's that? Yeah, we're going to chest him. Okay, let's cut him out here. Well, just for interest's sake, the lead wires are coming out of the edge of the capacitor rather than the center. Does anybody really care? I don't know. can't really read anything on here. Oh, wait a minute. Yes, we can. 0.1, 400 volt. Let's give him the test. How have you lasted? My clip lead's going to give out here very soon. Okay. 25 volts. What do you do? 50 volts, 50 volts. And it's just closed up like a clamshell. It's not going to open. So quite leaky. Could be because the physical dimensions of the capacitor are that much bigger. There's just that much more leak surface to leak through or across. Okay, so I'm going to put in a 0.1, and I think maybe we'll test the radio after that. Okay, that guy's in. Let's go after this guy. At least find out what it is. This one is connected to ground here, and the other end of it, where's it going? It's going to a terminal on the IF can. Is that an easily identified terminal? It has a 22 something resistor on it. There's a 22 something resistor going across two terminals on that transformer, and the capacitor is hooked up to one of those terminals. Okay, let's go looking for that. Let's start on the diagram down here again, and this capacitor is located in this area. Could be this one. Yeah, there we are. So this capacitor comes over. This terminal has R8 on it. That's got to be the 22 something resistor I saw. It goes right into the next terminal. So this is definitely it. C12. There's C15 right beside it. C15. Well, that's interesting. Look how they're showing these two capacitors. One is in a square box, rectangular box. The other's in a rounded off box. What's the significance of that? There's a rounded off box here. Those are probably the molded capacitors. Sure enough, yep, there's a molded one in there. Okay, that's interesting too. That's a little helpful. So what is this guy doing? He's connected to a ground terminal here. The other side, the other terminal. The other IF rather. Don't know what I'm looking at. So let's take a look at the circuit diagram. It's here. It's identified as terminal E. What was the capacitor number again? C12. So here's C12, 0.05, connected to one of the terminals. And this terminal is connected to another terminal through this resistor. 10 meg. No, that's going to a tube. I want to go to this. I want to go this way. So again, we look at C12. Get my landing here. Hey, there's no wire straight to another. That doesn't quite match. Maybe I saw it wrong. Is there another? There's another one over here. Well, this is a small capacitor. It's got to be this one. Oh, D, not E. Well, there is no E. There's no E. Wait a minute, there's an F. Well, what did they do with the E? A, no B, C, D, no E, F. And then the same thing over here, A, D, because there's more terminals on the actual device. And, I don't know, how's this add up? This is D, not E. This is E, D. Notice B has nothing connected to it. It's possible these are just spare terminals provided by the manufacturer of this transformer, maybe the radio manufacturer himself, for his own purposes. But I see B is not being used at all. Over here, same thing. B not used, E not used. I'm willing to bet this is nothing more than just a terminal point. So C12, but they show it connected to D. That's C15. Then where, okay, so if C, now, one of you was kind enough to warn me that you've noticed the numbering here is different than the numbering on the main diagram, on the main schematic, which is kind of crazy. That's crazy. Well, we want to find a grounded capacitor that's tied to the front end of this resistor, R8. If we assume R8 is numbered correctly, R8, oh, this one. Well, D is connected to R8. Now I'm getting totally confused again by looking at this stuff. So really we can think of this resistor and this capacitor as being connected where this wire goes. D. Okay. Hey, okay, I figured it out now. The C12 is connected here through this arrangement. And then R8 runs between these. This is on the other. It's on the other. Whoops. Yeah. Okay, what did I mean by that? This is like I'm having the room effect here as I switch from diagram to diagram. My memory's getting erased. So again, R8 between two terminals D and E on the second. That is the second IF, isn't it? Between D, there is no E. Here's a resistor, 22. I said it was a 22, but I didn't know 22 what. Of course, here's a 2.2. Where is clarity here? So this connection to D is made with a wire coming over here, picking up terminal E and picking up this part of the capacitor. So it's definitely this capacitor. Well, I could just leave it where it's located, not worry about it, and just replace it with a 0.05. And what kind of voltage is on this guy? So this is on the grid side of the circuit, so the voltage here you're talking 20 volts. 10, 20 volts, nothing more than that. So a low voltage capacitor will do the trick here. Okay, 0.05, I'll do it. Okay, let's cut this guy out. That's the grounded side. And here's the signal side. Let's just leave some wire behind. Because I never know what's going to happen next. I'm going to put a clip lead on there so I can't forget where it came from. There we go. Okay, and the capacitor. You know, I've cut it out and I think I put it right here. Did I put it there? 0.05. Okay, let's give them the usual abusive treatment here. The test voltage goes all the way up to 450 volts here. When I use this on these old radios, I never get much past 150 volts with these old capacitors, but they all should be able to go to 400. All the ones that are rated 600 volts for high voltage rating on should go to 450, and this eye should pop open. But boy, they don't get there. How about this one? Here we go. She's slammed closed. So a leak on this one. Now this is on a grid circuit. You know what? I'm going to look at the schematic again and ask myself, what could this capacitor do? I think this one can have a bad effect. Let's take a look. Okay, so it's C12, so it's this guy. So if he becomes more of a resistor and less of a capacitor, you see the impedance in here is very high. It's a high resistance circuit. These small charge variations cause big voltage changes. So if you're leaking a little bit of charge out of here, you can't necessarily restore it quickly through this 2 megohm resistor. So if the case is that the leak here is substantial enough, it could pull the voltage down on the grid. Also, if its capacitance is missing, if it's got no capacity, then you lose the signal ground from the bottom here, and the signal is being kind of mishy-mashied up into this thing. Well, important capacitor, I think. 0.05. Okay. Let's just let's change it. Okay, let's give this radio a shot here. Operating. Here comes the voltage. Just looking everything over. Good. Okay, dim bulbs are in. We're way down, 86 volts. Okay, it's working. Wonder what that is. Not that. Okay. A couple things here. Let's give it the full voltage. Where'd it go? The interference is, ticking interference is kind of overwhelming here. I wonder if I did not get this turned on. Oh! How can that be? Maybe we're not on the right band. This is probably push button, not sure. I gotta go make sure that antenna's switched on, because maybe it's not here. Well, this is not working out so good. Let's try a different antenna. So I'm hooked up to an outdoor antenna right now, but I'm gonna switch it to a loop antenna. This is the feed from the loop antenna, just behind me here. Jeepers. Took the antenna off, didn't really make any difference. Something not right here at all. Something is not right. I'm shorted. Am I on the broadcast band? Pretty sure I'm on the push button selector right now. Tuning should do nothing. Seems to do nothing. That terrible noise. What's happening? Okay, let's tune up the antenna here. Well, this is not a good sign. Looks like this radio's not really working properly. I think the next thing we have to do, we have to force in a signal at a known frequency. And look at that, there's just nothing happening with this antenna connection. Really, do I need to do any more? What's happened? What happened? Now I have no antenna hooked up. That's not going to help. Listen to the noise it's picking up. No antenna at all. Some bad actor here in my shop. I guess. I don't know. You know what would be good right now is some gulps of coffee, because I'm really kind of stumped here. Okay, I've skipped the coffee in favor of continuing on with trying to sort this out. So I've now got this signal generator operating, feeding a signal into the antenna here. I'm pretty darn sure I'm on the broadcast band. I believe I'm tuned down near the bottom, so say around 700 or something like that. So this is a fairly strong signal. This would be similar to the strongest signal you'd get from a regular antenna. Something like that is going on. So I'm going to knock down the strength in the signal generator and imitate a weak antenna. See a weak signal coming into the radio. And lots of radios can receive this level of signal. Not this one. What it is I'm not thinking of. I'm trying to think of what it is I'm not thinking of. 113 volts being supplied to the radio. This was working really well before, wasn't it? Or maybe it wasn't. I'm so confused. I've been listening to so many radios lately. I don't know which one's doing what to do here. Let's go back on the antenna. Wait a minute, why don't I fix the receive frequency to a known strong station? 680. So I'll set this to 680. Tune it in. Now we'll switch to the antenna. We should hear 680, a strong station from Toronto. Hear it now. Well, that was funny. It kind of, for a moment, it was really strong. I also turned off the antenna now. Antenna on. Off. It's as if it doesn't matter what's coming in on the So think about this now. This is interesting to me. The radio is showing tremendous sensitivity. It's picking up a signal with no antenna connected to it. Yet when I hook up an antenna, it makes no difference. Somehow the antenna has been completely isolated from the radio. Did I do that? Did I do that just now? Changing these capacitors? I don't think so. Neither one of them would be responsible for this. Who's responsible for this? Who else is around here? It's my cats. My cats have done it. I think I'm probably going to stop at this point. Then tomorrow I will try to sort of figure out what has gone wrong here. Do some signal tracing and stuff like that. Try to get down to the root of what happened. Did I make a mistake here? Maybe. I don't think so. Okay, I'm just going to leave it like that because I'm done for today. So thanks a lot for watching as I destroy this radio step by step. See ya.